In this problem we have a golf club hitting a stationary golf ball. We're shown a graph of force against time, showing how the force of the club varies on the ball as it makes contact. If we calculate the area of this force-time graph, we'll get the impulse of the force. We can split the shape up into regular shapes. Here I'm splitting the triangle up into two smaller triangles and using half base times height for the area of each. Notice how I'm using 0.04, that's because the scale is in milliseconds and I need to be in seconds to calculate impulse. So we find that the area under the graph is 4 Newton seconds. The units are Newton seconds because we have units of force newtons and seconds as the time. Multiplying them together gives Newton seconds. Now we can work out the change in speed of the ball. The impulse is equal to m delta v, and we're told in the question that the mass is 0.1 kilograms. Now that we know the value of I and m, we can substitute those into our expression and we can rearrange until we have an expression for delta v. So we have 4 Newton seconds divided by 0.1 kilograms. When we work that out, we find that the change in velocity is 40 meters per second. Note that this is the change in velocity, not the actual velocity. We need to go back to the question to find out the initial velocity. We're told the golf ball was stationary, so its initial velocity is 0 meters per second. With a change of 40 meters per second, that means that the final speed of the golf ball is 40 meters per second.